Hello, this is still Unit 4, Day 3, okay? And I'm going to finish up, I don't know if you guys will utilize this or not, but just to stay in practice. I'm going to do number 7 from the practice problems, and then I'm going to do number 6 from the homework, okay? So number 7, okay, just kind of finishing off this unit here, all right? On the grid shown, line M, which is the equation this, 2x minus 3, all right, is graphed along with this point right here, okay? So up above, all right, remember, what were we doing? We're reflecting things either over the x-axis, like we did here, the y-axis, okay? Sometimes you get, like you see here, you get a vertical line or a horizontal line, okay? And then sometimes we're asked to reflect over these two lines, right? Y is equal to x, y is equal to negative x, okay? But those aren't the only lines that we can reflect things over, right? Really just come up with a line and you can use that as a reflection line. So any sort of line will do, right? So we learned about the easier ones. Now we're going to talk about one that's a little more challenging, right? This is no longer, y equals x or y equals negative x. This is actually, well, it's still a linear equation, but we actually have a different slope, right? Our slope in this case is a 2, and our y-intercept is actually a negative 3, which you can see then, right? And then we're going up 2 over 1, up 2 over 1, up 2 over 1, okay? So let's think about this. Now we're going to have to reflect this point R over this line right here, okay? But in order to do that, and do that successfully and correct, okay, we need to make sure that whatever line we come, or whatever reflection we come up with, okay, this point, all right, will be equidistant, from here to wherever it intersects. I'm just guessing here, right? This isn't the exact, all right? And so it'll be equidistant on the other side such that these two measures will be the same, right? But then also, this line that we create, this reflection, okay, will create a perpendicular line segment with that reflection line, okay? So not only does this reflection, okay, is this point equidistant from that reflection line, okay, but also if we were to connect these two lines here, okay, we would create a perpendicular line segment to that reflection line, okay? And more importantly, okay, also this line segment we create, right, would be bisected by that reflection line, okay? A lot of terminology, a lot of stuff I was just using there, all right? So let's get down to the nitty-gritty here. Let's talk about this, all right? So going back to when we were creating perpendicular lines to particular, equations passing through a point, right? This is very similar, right? So think about it like this. I want to create a line, okay, that's going to be perpendicular to this line here, all right, and passes through this point, okay? So let's think about it like that, all right? So, and that's actually leads into letter A. I'm just over here talking, not realizing that letter A is actually asking about that. If R was reflected over the line to produce its image, what would the slope of that line segment be, right? So in order to create this reflection point, right, this line segment that would be created by R and R prime, okay, would have to have a negative reciprocal for a slope. Okay, so more importantly, if the slope over here is 2, then if we're going to create a perpendicular line, all right, or a line perpendicular to this line through this point, we would need a slope of a negative 1/2. Okay, that's what we would need, right? And also, we would need it to pass through this point. So let's just practice what we were doing before, right? So let's take this point. Okay, so I'm going to go y minus 3 is equal to a negative 1/2 x minus a negative 2, which is just give me a plus 2. Okay? So distribute that through there. Y minus 3 is equal to a negative 1/2 x minus 1. Add 2. Get y is equal to a negative 1/2 x, plus 3, plus 3. And that gives me a, stop it, get out of there, plus 2. Okay? So if we were to create an equation, okay, that would be perpendicular to this y equals 2x minus 3 and passes through this point, okay, this would be the line segment we would create. Okay? Now let's try that. All right? So I'm going to start by graphing this guy. So I'm going to start with my y-intercept, which is 2. All right? And I'm going to go down 1 over 2. And look, I fall right back on that line. Okay? And so let's take a look at how many times did I utilize my rise over run here, in this case I'm falling, before I hit that line. Well, it looks like I went down 1 over 2 and down 1 over 2. So if I were to create, to create this point, to put this point on here, that would be a reflection, I would have to go down 1 over 2, down 1 over 2 twice, and there is our reflection point. And as you can see, if we were to connect these two lines here, you would get a line segment which is perpendicular to that reflection line. Okay? So, our new coordinates is going to be 6, comma, negative 1. Okay, let's take a look at number 6. Okay, same sort of idea, except now, okay, we're actually reflecting an entire shape. Okay, so this is on the grid below, triangle MNP is plotted with these vertices. The line y equals negative 2 or negative 2/3 x is also drawn. Draw the image of triangle MNP after reflection over that line. Okay? So, let's talk about this. All right? This guy right here, right, its slope is a negative 2/3. So I would need a new slope, right? If I were to create any sort of line that would be perpendicular to that guy, my new slope would have to be a positive 3/2. Okay? And so now, using this slope right here, I'm going to count up 3/2 until I reach that reflection line. So up 3/2, up 3/2. And there it is. And how many times did I do that? Looks like I did it twice. So I'm going to go up 3/2, up 3/2, and right there is my new point, M prime. Let's do the same thing for the other guys. P, up 3/2, following the line, up 3/2, P prime. And we got a little bit of ways to go. So we're going to go up 3/2, up 3/2, up 3/2. So it looks like I did it 3 times. So I'm going to go up 3/2, up 3/2, up 3/2. Erase all these extra points here. This one is N naught, or N prime, I mean. And there, in all its glory, is triangle MNP. So give the coordinates. Okay, so M prime looks like it's negative 2, 10. N prime looks like it is 6, 9. And then P prime, 5, 1. So explain why MNP must have the same area, or explain why this triangle, I'm not going to say all those M prime, N prime, P prime, must have the same area as this guy here, because reflections are a rigid motion that do not change size or shape. Okay? So, anyway, hopefully this helps. And